Hi, so in the last couple of weeks, you've learned a lot about the differences and similarities between computers and brains, including touching on very interesting questions such as can computers have consciousness? And before that, for the first few weeks, you learned a lot about how neurons function and also how they connect together through synapses. So for the next few weeks, we're going to build on that and we're going to learn how networks of neurons, when connected together in quite large numbers, can produce important cognitive functions. These include working memory, decision making, and eventually consciousness itself. And in today's class, we're going to learn about working memory. We want you to understand what working memory is by the end of this video. Also, how it contributes to different cognitive functions. And finally, we're going to have a couple of examples to try and understand why working memory is important for real life. So let's start with this example. Imagine that you are cooking a dinner, a really important dinner for some good friends, and you want to have the best butter as an ingredient to cook for. This is the best butter. Okay, so you're going down to the supermarket, and it's really important that you get the image of this golden packet in your mind, and you keep that in your mind so that when you're going down the aisle, the dairy aisle of the supermarket, you're not distracted by inferior products, and that by the time you get to the selection of all of the different products, you're able to select the ideal spread for your cooking needs. Now, this is essentially what working memory is. Working memory is the ability to hold information in mind without sensory input over a period of seconds and also to manipulate it. And some examples of manipulation, for example, could be to just ignore the distractors and stop them from taking over your working memory. So make sure that you hold on that lovely golden packet in your mind until you've successfully bought the butter. Working memory essentially allows us to separate sensation from action. It has a temporary store of information in the mind that can be separated from what's immediately coming into our senses. So, with a complete absence of working memory, we would only be able to respond to things that we're currently seeing or sensing through our other senses. That means that all of our behavior would just be a reflex type reaction to whatever we're immediately sensing. So, working memory really is a cognitive function of itself, but it's also an important building block of many other cognitive functions. I'm going to start with an example of mental arithmetic. So, don't use any pens or calculators, and I just want you to do this multiplication in your head 14 times 13. Okay, so stop if you have the answer, or continue for another few seconds until you do. And I want you to think about how you came up with that answer. In my school in Ireland, when I was learning my times tables, we only went up to 12 times 12. So those are the ones I kind of know automatically. So this 14 times 13, I have to work out in my head. Now, I don't know how you worked this out, but I worked it out by, for example, multiplying 14 times 10, which is 140, and I keep that number in my mind. And then I multiply 14 times 3, which is 42. So then I've held on to the 140 and I have the 42 and I add them together to get 182. So you might have done this a different way, but it's likely that at some point you had to hold some information in your mind and then combine it or manipulate it in some way. So really working memory is a really fundamental component of mental arithmetic, which is itself a fundamental component of mathematical ability and many related abilities in academia. So here we see a good example of the maintenance and manipulation of information and how it can go on and affect your academic performance. So now we're going to look at how working memory can contribute to the understanding of speech, and it also contributes to the production of speech in a similar way. I'm going to read you a sentence from a scientific paper. The smallest of the URFs, URF-A6L, a 207 nucleotide NT reading frame overlapping out of phase the NH2 terminal portion of the adenosine trisephosphatase ATPase subunit 6 gene has been identified as the animal equivalent of the recently discovered yeast H plus ATPase subunit 8 gene. Now, how did you find that sentence to understand? Could you explain what was going on in the sentence? Personally, I found that a bit difficult to understand, and I think perhaps several of you might have found that difficult to understand as well. And now let's have a look at the sentence itself. Now, why is that difficult to understand for many people? A lot of people will think that it's because of the jargon or the technical language, and of course that doesn't help. But a major issue here is that the subject of the sentence, the smallest of the URFs, is separated from the verb, has been identified, by about 20 words. Now, readers or listeners expect the subject of a sentence to be immediately followed by the verb, and everything else in between is treated as a kind of a distraction or something of lesser importance. So effectively, to understand the sentence, you need to hold the smallest of the URFs in your working memory and not be distracted by all of these 20 or so intervening words until you can successfully link it with the verb has been identified. Now, this is a particularly complicated example, but you can imagine if you had a problem with your working memory, you may have difficulty understanding even quite simple sentences. Now, let's start to look at how working memory issues in real life could have serious consequences. There's a classic study by Susan Gathercole and colleagues that show that working memory can predict academic performance. So here is a figure from their study from 2004, where they look at two different types of working memory: the phonological loop, shown in black bars, which is more of a part of verbal working memory, and the central executive, which is more about manipulating the information in working memory. And here they compare working memory ability in the black bars and the white bars to performance on standardized exams for English, mathematics, and science. These are for 14-year-olds in the UK. And they've grouped children by their performance into low, average, or high stage performers. And on the y-axis here, we see their performance on tests of working memory ability. We see that for science, there's a big increase as you go from the low performance to the average and high that goes up with the central executive part of working memory and also the phonological loop part of working memory. So as working memory performance increases, so does performance on science tests. We see a very similar thing for mathematics, a strong relationship between working memory ability and test performance. And we don't see this perhaps as much for English language, but there does seem to be some sort of a relationship between the central executive part of working memory and English performance. So this tells us that this basic cognitive function, working memory, can have knock-on consequences on how kids perform in school. And for better or worse, school performance can have quite an important impact on access to the university, further education, and access to particular jobs. Working memory is also important for other reasons. So patients with schizophrenia tend to have three major types of symptoms. The positive or psychotic symptoms are most famous. These are things like hallucinations and delusions. There are also negative symptoms, which are like a lack of affect, for example, generally dulled emotions, a lack of motivation to go up and go about their daily lives. But there's also a third type of symptom, which are cognitive symptoms. And problems with working memory are a major part of these cognitive symptoms. And Green and colleagues have shown that when patients from schizophrenia are, for example, released from hospital or let back into the general community after a period of care, it's the cognitive symptoms rather than the other types of symptoms that are most predictive of their functional outcome. So, for example, whether they're able to successfully live independently, go back and return to work, and reintegrate into the community, for example. So this tells us that perhaps cognitive symptoms, including working memory, should be thought of more seriously as a target for medication and intervention in people with certain psychiatric disorders. So, to review the learning objectives of this short class, we wanted you to understand what working memory is. So, working memory is the ability to hold information in mind without sensory input over a period of seconds and to manipulate it. We want you to understand how working memory contributes to many different cognitive functions. And we gave some example of mental arithmetic and mathematics, and also speech comprehension and language. And we also wanted you to learn some consequences of working memory breaking down, or to understand why working memory may be important for real life. We understood that if you don't have working memory at all, it would be quite a weird state where all of your behavior is just a reflex. We also saw how more subtle working memory impairments can lead to poorer academic performance, and also for some patients, for example, with schizophrenia, a reduced ability to function independently in society. So that's our first introduction to working memory. And in the next video, we're going to learn about how working memory seems to be expressed in neural activity in the brain, and learn a little bit about some models of how we think that may happen by communication between networks of neurons. Thank you very much.